Hi and welcome. So in this video we will see how to upload a Arduino sketch in an Arduino board, and before that we will see the very important significant functions in Arduino IDE. So these are all the 10 important functions, or otherwise it may be called as API commands in Arduino IDE. First one is pin mode. Pin mode, it is having the syntax called, it is having the input arguments like pin number and mode of operation. So if you want to set a particular device as input or output, you have to use this command pin mode. So as a first argument you have to tell the pin number first, and then mode of operation, it may be input or output. So this is the pin mode command. The M should be caps. Then digital write. If you want to send the digital signal outside to that board, there is a LED or buzzer or some other relay is connected to that Arduino board, you have to tell whether the LED or buzzer has to switch on and off. So there are two states only for digital signals. We are having only two states, zeros and one, are low or high, that's all. So this is so called state, right? So digital write, the input arguments are again pin number comma state. So if you want to give the state as high to the LED which is connected at the 10th pin, first you have to tell the pin number and then the state of that particular device, right? So digital write of pin number comma state. Then third one is digital read. So it is the reading command. So either from the digital device we can either read 0 or 1. So we don't know the actual data, but we know only the pin number, right? So as an input argument we will give only the pin number to this command, that is digital read of pin number, that's all. So after reading the data is actually available in the Arduino workspace. We need to collect it. Actually to the left side of that equal symbol we will have a user defined variable name, that is returned underscore digital underscore value. So it is a user defined name. You can name it you can name with any kind of a number or alphabet, but you should not give spaces. You can use underscore. So this is a user defined variable name. Then fourth one, delay time. Fifth one, delay microseconds. Within the bracket we are giving microseconds as a input. The fourth and fifth commands or API commands are dedicated for providing delay. Fourth one is giving delay in terms of milliseconds. So as if you are giving 1000 within that bracket, the Arduino will take the 1000 as 1000 milliseconds and it will produce 1000 milliseconds of delay. So it is approximately 1 second. Then delay microseconds. So there is a dedicated command is available in Arduino IDE for producing microseconds time interval. So if you are giving 1000 means the delay microseconds bracket, within the bracket 1000, it will execute a delay of 1000 microseconds, that's all, right? So this is the delay commands. And then sixth one, analog write. So similar to digital write, this is analog. This is the dedicated command for writing the analog value to the device which is connected at the analog pin. So first you have to tell the pin number and then analog value. What you have to write from 0 to 255 you can write. So in Arduino UNO I am speaking, it is possible to give 0 to 255. 2 power 10 bits of data, 2 power 8 bit of data you can able to send, since it is a 8-bit microcontroller. So minimum you can send 0, maximum you can send 255. So this is so called analog value. So before we told digital values, that is only two states, 0 or 1. Here we are having 256 numbers, so called this is analog. So analog means continuously varying one parameter, that's all. So within the bracket, in the analog write command, tell the pin number and analog value, that's all. So this is the command for analog write, and followed by seventh one, analog read. This is very similar to digital read, where we are mentioning the pin number. Here we are mentioning the analog pin number. We know that in Arduino UNO we are having A0, A1, A2 up to A5. Similarly, we are having 6 analog pins. So this analog pin has to be represented as an input argument for this command. So the received data from the sensor or any other input device, I mean the received analog data received from the device is actually now available in the Arduino workspace. Now you have to properly receive with the help of a variable name. So to the left side of that equal, I have mentioned returned analog value. This is also a user defined variable name. And 8th, 9th, 10th, these are all the serial command. Serial.begin baud rate, serial.println, serial.print. Serial.print begin. So actually serial is a class in Arduino. So if you want to communicate, if you want to get the data from board to the computer again, first one thing, if you are writing the code and sending the code to the Arduino, means this is a serial communication from computer to Arduino, right? So Arduino is collecting the data, and from the Arduino board itself, if you want to collect the data and you have to publish into the screen, means the data will be transmitted from Arduino UNO to again the laptop. So this communication is so called serial communication. Since we are connecting the entire setup with the help of universal serial bus, so it is a serial communication. You should begin this serial communication. If you want to, I repeat, if you want to get the data from Arduino UNO and if you want to push into Arduino IDE at laptop, you need to use this command like serial.begin baud rate. Baud rate is nothing but bits per second. Okay, the unit for the baud rate is bits per second. For single second, how many bits has to be transferred. This is so called baud rate, because my laptop is working in different frequency, my Arduino is working in different frequency. So each device is working in separate speed, right? So we are telling a common speed. If you want to make the data transaction without any loss, without any drop of any data packet, if I want to send if you want to send as well as receive the same data from Arduino UNO to laptop, you have to set the same speed between the two devices. So called baud rate is fixed. So usually we fix the baud rate in 2 to 3 different rates like 4800, 9600, 11,000, 1,15,200. These are all the different standard baud rates. So we usually use 9600. And then serial.println. So we are having serial monitor in Arduino IDE. So in this Arduino IDE itself, if you want to print any data, I mean sensor data from the Arduino board is actually received into the Arduino IDE with the help of analog read or digital read, whatever it may be. If you want to print the data, okay, where we can see, yes, we can see in serial monitor. There is an option is there, I will show it later. So if you want to print the data in that serial monitor, we need to go for again you need to go for the class called serial. Take that serial class, and within that you can take the command called print or println. Just you can send the data. If you are sending with the double quote, that will be considered as string, and string will be printed. If you are not sending with the double quote, it will be treated as a variable name, and that value behind the variable name will be printed. The difference between serial.println and serial.print is println is line printing, one by one it is printing. Serial.print will continuously printing the data whatever you are sending, right? So these are all the very important commands you need to know before working with Arduino UNO. So this is a Arduino IDE. So this Arduino IDE, I mean this is a version Arduino 1.8.18 that is I am using here, and the Arduino is connected through the USB cable, and it is connected at my USB port. And if you want to execute a simple exercise, I suggest you to go to File, Examples and Basics and Blink. While you installing the Arduino software in your laptop, these examples will be automatically uploaded, and these are all the explanations whatever the Arduino community has already given. So it is hidden actually. So LED built-in, this is the command. Actually there are two commands, as you can able to see, void setup and void loop. If you are opening a new Arduino file this is the actual welcome screen. So where there are two different functions, as we discussed earlier. There are two different functions. One is dedicated for hardware setup, one is for main program, and this is the command. This is the very basic experiment for a classical experiment for understanding the Arduino program, and where we are going to blink the 13th pin LED. So there will be a LED which is already fixed mounted at the pin number 13th. So we know that LED is a digital device, so you can connect at anywhere, but the default LED is connected at 13th pin. So pin mode, I am using pin mode command. Pin mode, that is actually I'm just explaining this setup command. Pin mode LED built-in comma output. So LED built-in is a secret key where it indirectly means 13, right? So it is a predefined term in Arduino. So if you are using LED, I mean default pin, I mean LED underscore built-in, that is inherently means digital pin 13, right? So you can use LED set to correct LED pin independent of which board is used. Okay, so LED, according to the different types of Arduino boards, the LED built-in will change, right? So Arduino LED built-in is 13, right? So as they already mentioned, on Mega and 0, it is attached to digital pin 13. Okay, on MKR 1000 pin number 6. Okay, so according to the board type it will change, right? So you can take it as 13 or otherwise LED built-in, whatever it may be. The very important thing is you are mentioning the pin number and the mode of operation. So this is the very important command that is under setup command. Then we are going for while loop. So digital write pin number comma state, right? This is the syntax. So digital write built-in comma high. Then delay for 1000 milliseconds. So wait for a second, a single second I am going to wait, and again I am going to call the same command digital write and LED built-in and low. This is the command for switching off the LED, and again waiting for 1 second. So this is the sequence of operation what I am doing as a blinking operation. So LED high, delay 1 second, LED low, delay 1 second, again LED high, 1 second delay, LED off, 1 second delay. This is the continuous loop operation I am doing. So how to upload this board, upload this code? So first of all you have to know these are all the very important options given in Arduino IDE. So this is verify symbol, right? So this is verify. This will compile the entire sketch. As we discussed before, compilation is very important in Arduino. In any embedded programming languages, compiling is a process of finding the mistakes, finding the syntax errors, verifying. It is entirely verifying whether the predefined APIs are used or not. Okay, so it will be helpful to find out the human error as well as the careless mistakes. In addition to that, it is compiling. Compiling means not only debugging, it is compiling the entire code. It will convert the entire code into a hex format. So already we discussed, right? So we are talking in higher level language. The machines are only in the machine level language. So we need a converter from higher level language to machine level language. So called compiler is working for it, and compiler, after debugging your entire code, if it is okay, it will report to you compiling done. So at the moment it will convert the entire sketch into hex format. That is the actual happening here. So we are running and we are compiling our sketch. You can able to see at the bottom side this ribbon is reporting you compilation process is going on. Then followed by we need to upload the code. Before upload the code, I need to select the board type and COM port, right? Yeah, as you can see in the figure, yeah, the compilation process was done and it is intimated here, done compiling. Now go to the tools and then board. You have to go to this command, this option, and Arduino UNO. I'm using Arduino UNO, so I'm just clicking this option, and again I'm going to the tool and port, and my OS is actually finding COM port 14, that is communication port 14 as Arduino Uno. Just I am selecting. So if it is not selected, I mean the board and port, if it is not selected, you have to manually select at first time. So then further automatically your OS will be automatically identifying these things, so no problem. So after ensuring this option is correctly selected, okay, if you are using different boards of Arduino, then you can go to this option and you can choose any board whichever you are using, either it may be Arduino Gamma and Arduino BT, Fio, Mini, whatever you have to choose correctly. Then COM port. Now come to this command, that's this option, upload. Now if you are clicking this option, again the Arduino IDE will compile it again and it will upload. Okay, without compiling it will not upload, either if you are pressing compile verify command or not. If you are pressing upload, it will again verify the same code and it will send the data to, and after compilation process over, it will send the data to, the code to Arduino IDE, Arduino board, sorry. So again the compilation process is going on. So after compilation process is over, it is uploading the code and also it is reporting done uploading, right? So now you can able to see the built-in LED in Arduino UNO board is blinking with 1 second interval, right? So now if you are reducing the time by 500 milliseconds, that is 0.5 seconds, again I am uploading the code, right? So again the compilation process is going on, and after compilation is over, the uploading will start. So now you can able to see the light is blinking with somewhat faster than the previous one, because previously we uploaded the code for blinking the LED within 1 second time interval, but now the LED is blinking 0.5 second interval. So still the code is getting compiled. Yes, it is about to end. Yeah, uploading the code. Yeah, now done uploading. Check the Arduino board now. Now it is blinking with 0.5 second time interval. Okay, as you can see, you can able to reduce the time as 200 milliseconds, that is 0.2 seconds. So it will be more faster than the previous cases. Whenever if you are uploading the code, it will compile it and then it will upload the code, right? So again compilation is going on. Once the compilation is going, the compilation process is completed, the code is now uploaded to the board. Yeah, it is, the code is now uploaded. Now you can able to see the LED is blinking more faster, within 0.2 seconds interval it is blinking, right? So if you are making any mistakes with the commands, like if I am mistakenly typed digital write, okay, so you can able to see while compilation process, it will find the bug and it will report to you here. Okay, in this black ribbon space it will report and it will mention the line also. As you can see, the API commands will be represented in orange color. Okay, for this line it is remarked as black color. Okay, the Arduino IDE is found it as a user defined variable name, that's all. Okay, so if it is digital write, a correct API command means the W should be in caps. Okay, if it is not caps, Arduino IDE is identifying it as a variable name, that's all. Okay, So as you can see, so it is correctly reporting it is a bug. Digital write was not declared in the scope. Yeah, it is, I already told, right? So Arduino IDE is finding this term as a separate variable, so it is not declared it anywhere, so it is telling that that as a mistake. And also this pink color ribbon, that is actually correctly mentioning that mistake. Okay, so these are all the process. Okay, by the way, you can able to type the code and upload into an Arduino board.